Welcome back, everyone, to the Deep Dive. We're diving into something today that might seem like a small detail, but could have, big implications for the future of AI.
Oh, yeah.
Yeah. So think about those large language models, the things behind ChatGPT, and how they can sometimes, give you like a wall of text when you just wanted like a quick answer.
Yeah, it's a problem. It's been bugging researchers for a while now.
Right. Like, how do you get these LLMs to be precise with how long their responses are? Like, without, sacrificing the quality of the information. And that's exactly what this paper from researchers at Raytheon UK is trying to solve. They think they found a way to, fine-tune these models.
Okay.
To be way better at hitting a specific word count, so to speak.
Interesting. So they're not just, shortening responses. They're aiming for, what, precise control?
Exactly. Like, you want a 50-word summary. Bam, you get a 50-word summary. You need a 200-word analysis. That's what the model delivers.
Wow.
No more get it like a novel when all you asked for was a tweet.
Right. Sign me up. But how do they even do that? It's not like LLMs come with a built-in word counter or something.
Right. It's not that simple. The key here is this technique that they're calling length difference positional encoding, or LDPE. And, positional encoding is just a way of giving the model information about the order of words.
Yeah.
But these researchers have, flipped the script.
Flip the script? What do you mean? Okay,
so instead of, a steadily increasing counter, they made it a countdown.
Huh.
Yeah, it's like giving the model a token budget.
Yep.
Each word, each piece of punctuation, it costs a token.
Okay.
And the model has to learn how to spend those tokens wisely to reach the target length.
So the model is constantly aware of, how much space it has left to respond.
Exactly.
Clever. But are LLMs, they're complex things, right? Did they actually manage to teach the model to, budget its tokens effectively?
They did. And they tested it out in a really clever way, too. They focused on two common tasks for LLMs, question answering and text summarization. And they didn't use, just toy examples. They used established data sets. They even compared their results to models like GPT 3.5.
Okay, so how did it perform? Did they actually get these LLMs to stick to a strict length?
Okay, so hold on to your hats because the results are pretty impressive.
Oh.
When it came to question answering, they achieved near perfect length control.
Near perfect. So they were hitting the specified token count almost every time.
Pretty much.
Yeah.
And here's the kicker. The quality of the answers didn't suffer.
Wow.
Even with those strict length constraints, the models were giving accurate and insightful answers.
Amazing. What about the summarization tasks? Were they able to get concise summaries without losing any crucial info?
That's where things get even more interesting. So it turns out they actually exceeded the accuracy of those simple prompt-based methods that we talked about earlier.
Oh, really?
Yeah. So they compared their summaries to the ones from GPT 3.5.
Okay.
And their fine-tuned models consistently had much smaller errors in length.
So not only did they manage to control the length, they did it better than the usual ways of trying to limit LLM output.
Yeah, but hold on. It gets better because they knew that sometimes you don't need an exact length, but rather a maximum limit. Think about writing a tweet or a headline. You don't want to go over the character limit, but you might not need to use all of it either.
Right.
So how did they tackle that? Did they create a whole separate model for situations like that?
No, that's the genius part. They added this little twist to their original LDPE method. They called it max new tokens plus plus. So basically, instead of, a fixed token budget, they added some randomness to the training process.
Okay.
It's like the model learns to work within a range instead of aiming for just one single target.
So it's like giving the LLM some wiggle room.
Yeah, to be concise, but also complete.
That's fascinating. It sounds like this approach could have a lot of practical applications.
Oh, it really does. But before we jump into all of that, I think we need to step back and look at how this LDPE magic actually works,
Okay.
It's one thing to say, oh, it's like a countdown timer.
Right.
But how does that actually play out within the complex workings of an LLM?
Okay, yeah, I'm with you. We've been talking about this, token budget and this LDPE countdown. But I gotta admit, it still feels a bit like magic to me.
Yeah, sure.
So can we pull back the curtain a little bit, see how this actually works inside the LLM?
Absolutely. So it all comes down to how the model understands the order and the importance of words. See, traditional positional encoding, it's giving each word in a sentence a numbered ticket, in line. Word 1 gets ticket number 1, word 2 gets number 2, and so on.
So the model knows which word comes first, second, third, all that. Makes sense. But you said that LDPE like flips this.
Exactly. Imagine you're writing a short story and you have like a really strict word limit. Instead of like numbering the words from the beginning, you actually start counting down from that limit.
Oh.
So you're like, okay, I have 5 words left, 4 words left, 3 words left. That's essentially what LDPE does. It gives the model this reverse countdown, so it always knows how many tokens it has left.
So the model is constantly thinking, okay, I've got 5 tokens left, better make these count.
Exactly.
And I can see how that would encourage more concise responses. But doesn't that also risk, cutting off important information?
Yeah, that's a great question. And it's where the cleverness of this approach really shines. See, the researchers didn't just like slap on this countdown and call it a day. They fine-tuned the model, specifically training it to work with this token budget system.
So they're essentially teaching the model to be like a master of brevity, like a literary Marie Kondo, only keeping the most essential information.
Yeah, that's a great analogy. It's like the model is learning to prioritize information. It's like this word, crucial, gotta keep it. This phrase, nice but not essential, gotta cut it. And through this training process, the model actually becomes more skillful at expressing ideas concisely without, losing the core meaning.
It's almost like learning to write haikus, right?
Yeah.
You've got a limited number of syllables, but you still need to convey a complete thought or feeling.
Yeah.
Now, I remember you mentioned that the researchers tested 2 versions of LDPE, LDPE itself and ORPE. What was the difference again?
Right. So that gets to the heart of how these decoder-only LLMs process language. Remember, they see both the user's prompt and the model's response as just one continuous stream of information.
Right.
It's like reading one very long sentence.
Right, so the model doesn't necessarily see a clear separation between what the user asked and what it's supposed to answer.
Exactly. And that's where the 2 versions of LDPE come in. With just LDPE, the countdown applies to the entire sequence, including the prompt. But with ORPE, it only applies to the model's output.
So with LDPE, the timer starts ticking from the very first word of the prompt.
Yeah.
But with ORPE, it only starts when the model begins responding.
Precisely. And it's a very subtle difference, but it raises a really interesting question. Does including the prompt in that countdown affect the model's performance?
Yeah, that's a good point. You'd think including the prompt would make it harder, right, for the model to budget its tokens effectively. I mean, it's essentially starting the countdown earlier.
That's what I thought too. But surprisingly, both versions did exceptionally well.
Oh.
Yeah. And there wasn't a significant difference in their ability to control response length or, maintain that quality of the output.
So maybe the model is smart enough to recognize the prompt as, like, separate information.
Yeah.
And adjust its token budgeting accordingly. Like, it knows those tokens are already spoken for.
That's a fascinating possibility. It kind of suggests that the model might be developing like a deeper understanding of the structure of conversation and the distinct roles of the user's input and its own response.
Okay, my mind is officially blown. This is incredibly impressive, but I have to ask, are there any limitations to this approach? I mean, it can't be like a perfect solution for every situation, can it?
You're absolutely right. While the results are super promising, there are still some, questions and challenges that need to be addressed. For example, the researchers focused on specific types of LLMs,
Okay.
Mistral 7B and Llama 3 8B, and they tested them on these established data sets. But what about other LLMs with different architectures or trained on like vastly different data?
So we need to see if this approach can be generalized to a wider range of LLMs before we start, celebrating the end of rambling AI responses.
Exactly. And that kind of leads to another important question. Can this LDPE method be scaled to even larger models? Remember, we're talking about models with billions of parameters.
Right.
Can this token budgeting system keep up with the complexity of these massive models?
It's like wondering if a navigation system that works perfectly in a small town will be just as effective in a sprawling metropolis.
A perfect analogy. And there's another potential limitation we need to consider. What happens when you push the model to its absolute limit? Like, what if you ask for a 10-word summary of a complex scientific paper?
Yeah, you can't squeeze a novel's worth of info into a tweet and expect it to still make sense.
Exactly. There's likely a point where the model just can't condense the information any further without, sacrificing coherence or accuracy.
Yeah.
And figuring out those limits is crucial for understanding the practical applications of this approach.
So it seems like there's still a lot to explore and understand about this LDPE method and, its potential.
Absolutely. But even with these limitations, I think this research is a major step forward in the field of LLM control. It opens up a whole new world of possibilities for how we interact with these, powerful language models.
And speaking of possibilities, I think it's time we, shifted gears a little and explored some of the potential applications of this technology.
Okay.
After all, it's one thing to control the length of an LLM's output, but what can we actually do with that control? Yeah, you're right. It's time to move beyond the how and start thinking about the what. So if we can truly control the length of LLM output like this, what are some of the real-world applications that you're most excited about?
Oh, man. The possibilities they're mind-boggling, really. One area that just immediately comes to mind is, content creation. Imagine being able to just give an LLM a topic and say, write me a blog post, exactly 600 words, with a humorous tone, targeted towards, this specific audience.
And it delivers.
It delivers.
No more agonizing over word counts or struggling to find that perfect balance of information and entertainment.
Exactly. It would be like having this custom tailored content generator, right? Just like that at your fingertips. But it goes beyond just blog posts too. Think about writing marketing copy, press releases, even scripts for videos.
Wow.
The applications are kind of endless.
And it's not just about generating new content either, right? This technology could be really powerful for summarizing existing information. Imagine being able to ask for a 100-word summary of a dense scientific paper.
Right.
Or a 200-word overview of a historical event, or a 500-word breakdown of a complex legal document.
Yeah. That would be a game changer for students, for researchers, for anyone really who needs to quickly grasp the essence of, complex information.
Yeah.
We could say goodbye to information overload.
Speaking of information overload, think about the potential impact on news consumption. Imagine a world where you can personalize your news feed based on not only your interests, but also the amount of time you have available.
You could say give me a 5-minute rundown of the top news stories, or I've got 30 minutes, give me a deep dive into the latest developments in climate science.
Right.
It would revolutionize how we stay informed.
It would be like having a personal news curator that tailors the content to your specific needs and time constraints. No more skimming headlines or feeling overwhelmed by just this endless stream of information.
Another area that I find really exciting is chatbot development. Imagine chatbots that can just seamlessly adjust their response length and their style based on the flow of the conversation.
Oh, interesting.
Yeah, no more of those robotic, one-size-fits-all answers.
Right.
We could have chatbots that are witty, engaging, and genuinely feel more human-like in how they interact with us.
Yeah, that would be a huge leap forward in creating more natural and intuitive human-computer interactions.
Absolutely. And let's not forget about the potential for accessibility. We could use these length-controlled LLMs to create simplified versions of complex texts.
Okay.
Making information more accessible to people with, cognitive disabilities or those learning a new language.
It'd be like having a universal translator.
Yeah.
That not only translates languages, but also adjusts the complexity and length of the text based on, the individual's needs.
Yeah.
That's a powerful and inclusive application.
It really is. And it speaks to the broader impact of this research. It's not just about making LLMs more obedient or more efficient. It's about using these advancements to create a more human-centered and accessible, technological landscape.
Well said. But with all this talk about these, amazing possibilities, it's important to remember that we're still really early on in exploring this technology. There's still challenges to overcome and, questions to answer before we see these applications fully realized.
That's true. As we've, discussed earlier, we need to see how this approach generalizes to other LLMs, right? And how it scales to these even larger models.
Yeah.
And we need to be mindful of the limitations, recognizing that there's always going to be a point where condensing information further means we have to sacrifice coherence or accuracy.
It's like any new tool or technology, right?
Yeah.
We need to understand its strengths and its limitations. We need to use it responsibly and ethically.
Yeah.
But that doesn't mean we can't be excited about the potential, right?
Absolutely not. This research has opened up a whole new frontier in our understanding and control of LLMs. And while the future is always, uncertain, one thing is clear. The possibilities are immense.
It really is an exciting time to be witnessing like these advancements in AI. Who knows what other breakthroughs are just around the corner? But
Yeah.
for now, I think we've given our listeners plenty to ponder.
We've covered a lot of ground today, from the technical intricacies of LDPE to the, far-reaching implications of length control in LLMs.
So to our listeners, as you continue to explore the, ever-evolving world of AI, remember to keep asking questions, keep challenging assumptions, and keep diving deep
Keep diving deep.
into the fascinating world of research.
And join us next time for another deep dive into, cutting-edge science and technology. Until then, stay curious.
Thanks for listening.